Okay, so definitely just got cut off right in the middle of revealing how to figure out these ties, which you do have ties. So, really, the way to figure out a tie is you just check molar mass. So, the bigger molar mass is going to win ties. So, when I say molar mass, just add them up on the periodic table. So this would weigh about 32 oxygen. So, they're each 16. So, that weighs about 32. And this one is going to weigh, these guys are 14s. So, it's going to weigh about 28. So, if you had to pick one, you would go with this one over here because it weighs more. So it's a tie, but you're going to go with the O2. So the O2 has more mass. Now that's only for ties. So don't confuse that with like everything. It's just for ties. Not everything is going to be tied. So take a look at the next one. Once again, we're going to check for all of the types of forces. So we're not just going to um, um, look at it and only check for dispersion or dipole. We check for each one. So let's take a look at what we got here. We got NO, and then we got O2. Well, we already know what O2 has, right? Because we just did it. O2 only has dispersion. That's it. Okay, so what about NO? Okay, so let's go through. Well, nitrogen and oxygen are both nonmetals. Now, I could complete the dot structure. That might be important, but I can tell it's polar without doing it. But I'll go ahead and do the dot structure real quick. Actually, we don't need to do dot structure. I think we're fine with that. It like there's a bit of an issue with this dot structure, but we don't need to get into it. So let's just look at it like that. There we go. NO is polar because these are not the same element. So the electrons have to go somewhere. So since they're not the same, it's polar. So that means that this one has an extra force. It has dispersion, but it also has dipole forces. So this one has two forces. Now, it doesn't have any H bonds because it doesn't have any hydrogen, but it has two forces. So which one has the higher boiling point of this set? It's the NO because it has two forces. So more forces is better. So 2 is better than 1. 3 is better than 2. And then the hydrogen bond is really sort of the king of all the forces, and that's the best one. Now remember, as a general statement, we're only comparing weak forces. These are all weak forces. They're in gases and liquids. They're not really hard materials, but we can predict some things from this. So let's go ahead and look here. Great example. I want you to try to do this. Which is going to have the higher boiling or melting point? It doesn't matter. We're looking for the one with the strongest forces or the most forces. Okay, so go ahead and see if you can figure out what forces each of these have and kind of give this a whirl. Check for each one. Check for dispersion. Check for dipole. Is it polar? Check for H bonds. If it has all three, it's better than if it only has two. If it has two, it's better than if it has one. So. All right. Hopefully you paused it. You went through. You tried to figure out what forces these have. So we're going to take a look. So oxygen, we've done this a bunch. So we kind of know what oxygen has. And then here's hydrogen. So we got oxygen or hydrogen. So we know that the oxygen has dispersion, and that's it. And then the hydrogen looks like that. And guess what? It also only has dispersion. Now, why doesn't it have hydrogen bonds? Okay, so let's go revisit the definition for a hydrogen bond. you have to have H attached to N, H attached to O, or H attached to F. You have hydrogen, but you don't have the hydrogen bond. So this one is the best because it's going to weigh 32 and this one weighs about 2. So in terms of a tie, I go that route. Okay, SO2 or CO2. So you kind of need to draw these out because you need to kind of figure out, are they polar or not? If you're just guessing, well, I guess you're just guessing, not the best plan. So here's SO2. And the target number on SO2 is 18, right? But this is 20. Target number is 18, but this is 20. So I'm going to have to put a double bond in, and then I'm going to have to erase a pair from each side. So that one is polar. Let's do the CO2. CO2 ends up looking like this. And again, you can do the dot structure on your own to verify, but it's going to look like that. That's not polar. So the SO2 gets dispersion, but it also gets dipole. So it gets 2. And this one only gets dispersion because it's not polar. No H's, no H's. So we're going to go this one because it has 2 forces instead of 1. HF or HI? Okay, HF is polar. HI is polar. They're both made of nonmetals. So this one has dispersion. This one has dispersion. This one has dipole. This one has dipole. But here's the difference. HF also has H bonds. So it has all 3. So this one has 1, 2, 3 forces. So it is the better of the 2. Okay. SiH4 is going to look like this. Probably better different pen. There's my I. So that's SiH4, and then the GE. They're going to basically both look like that. They have, both of them only have dispersion because they're not polar. So they can't have dipole, and they don't have H to F, N, or O. So once again, H bonds have to be those specific attachments. So these are just dispersion. So we have to go to mass. So if you go to the mass, the germanium weighs a little bit more than the silicon. And so then you would end up using the germanium because we would use the more mass. So the mass is going to be the tiebreaker there. Okay, CH4 or CO. Okay, I'm going to go put those, I think, over here, running out of space. So CH4 methane looks like this. And then CO is going to be polar. So see, this one is polar, and this one is nonpolar. And so that is a huge difference because this one is going to have only dispersion right here. Because again, this is not a hydrogen bond. Like that is H attached to C. So again, it doesn't meet the criteria for the H bond. And so then over here, C to O, that one is going to be polar because see, the C and the O are not the same. So you've got the dispersion and you've also got the dipole and then you don't have the H bond. But you have 2 instead of 1, and so that's a good thing. And so then that is going to be what we go with. We're going to go with the CO because that's 2 instead of just 1. F is really, really hard. I doubt you would probably get that one right because they both have all 3. So you end up with this weird tiebreaker for all 3 because it's going to look kind of like this. So they both have all 3. So if you look at the tiebreakers, if you have more hydrogen bonds, it's a little bit better. If you're more electronegative, it's a little bit better. This is just, you can't figure it out. I would just look this one up because this is just a flat out tie. I wouldn't use mass because you're going to have 18 on basically on both sides. And so really the tie doesn't work. So you want to look that one up. And the last one, octane. If you look really close to the notes, if you stretch a molecule out, it's a little better than if it's compacted. And so you'd actually go with this one here. F and G are really not, are just sort of curious because some things you can't predict by looking at. So something a little bit different there. Again, you have to be able to draw a dot structure to get these things to work. And so if I can't do this, then I'm really going to struggle on all the things on this test. So get into melting and boiling points here. We'll do this on the next video. Goes pretty quick. We'll be looking at different forms of carbon. I've got some things to show you there. But main thing to take away from this video was just, can I rank the 3 forces? If it's got 3, it's better than 2. If it's got 2, it's better than 1. And they're really restricted to nonmetals.